Hello everyone, this is going to be our recording for the first tutorial where we're just going to go through the code and give everyone kind of up to speed on what's going on here. The tutorial itself should be fairly self-explanatory. If you have any questions, please do get on the discussion board. But for the recording here, what I'm going to focus on are the R and RStudio elements of the tutorial. And what you'll need to do is you'll need to go over and you'll need to grab the code from our GitHub page. And if you navigate to the link that I've got there on the tutorial on Canvas, you're going to see a number of files. There's one that's called an RMD file. That stands for R Markdown. That's what we're going to be working with. And then when we do an R Markdown file, it renders other files that are more readable for us. For example, we can create this file, which again is a version of the tutorial that's already kind of pretty. It's been rendered by RStudio into something we can read and go through. And you'll copy all of this code and paste it into your RStudio session, and then we can execute this code. That's how you'll do it. And so now I'm going to go through this code over in RStudio and tell you what all the things are. So the most important thing to point out here is that we're working for what's called an RMD file, an R Markdown file. Now normally when we do things in R, we would use an R script, which just looks like this. And if I want to create some code, so here I'm going to create an object. This is the object I'm going to create. It's called X. I'm going to use an assignment operator, which means I'm going to assign some value to that thing, and I'm going to make it a group of numbers, a vector of numbers. And when I do that, I'm going to see quickly here, starting from scratch, I'm going to see that I've created this thing in my environment. It's called X. It is some numbers. There's 3 of them, 1, 2, and 3, and their values are 2, 3, and 5. And then I could create another object, call it mean X, and now I'm going to use a function. I'm going to use it on that object I just created and create a new object, and that is called mean X. So this is usually how we do a lot of our stuff in R. And basically the script means that anything written in it is code that can be executed. And if you'll remember, R can be very complicated at first, but at the end of the day, everything we're doing really comes down to this idea of we have objects and we assign values to objects using assignment operators, and we take a function where we do something to that object and then create a new object. That's what everything we're going to do is. Okay. So if we're using scripts, then every line here is eligible to be executed by RStudio, unless we put a hash there, and then we can add comments. All right, so if I do and try to execute this line, so I put my cursor on the line, and I usually hit Control Enter, nothing happens. If I put my cursor here on this line, I hit Control Enter, something does happen. It created this X all over again. Or I could just highlight this bit of code, and it will spit out the results into the console. Okay, so that's a normal R script. But what we're going to use is a thing called an R Markdown file. Now what's magical about R Markdown files is it allows us to combine plain text with code that gets rendered, and then it gets knit, is the kind of term we use, all together into some kind of a readable document. And we can knit these documents into Word documents, into PDFs, and into HTML files. So they become very, very useful for writing up the results from a study and so on and so forth. And what's really good about them is that if you use them consistently, if you have a situation where the data changes or you need to change something in your analysis, you identify an error or something else, but you've already done the paper, then you can just rerun your R Markdown file, which will combine all the text from your paper and all the analysis and all the plots. So you can make the little change, rerun everything, update everything without having to be cutting and pasting back and forth between your statistical software and whatever word processing you're using. So moving on, if we talk about an R Markdown file, first we have this section at the top which is called the YAML, Y-A-M-L, and it's just the one set of controls we can use to control the output and the appearance of the R Markdown file. All right, so we can talk more about those little options later on, but here we have simple stuff. We're going to give it a title called frequentist inference, and importantly, we're going to output to an HTML document, but I'm going to keep MD, this stands for keep markdown, because this file actually can be rendered on GitHub. So I can put everything up on GitHub where everybody can see it rendered and see the raw code, which is this markdown file. Now, here in the markdown file, what you can see is kind of two types of sections. This section is called a chunk. A chunk is where we can put in code that will be evaluated just like it would be in a script. The other sections down here are just our plain text. Now I say plain text, but actually we can use Markdown, which is a markup language, in order to create things like headings and to create emphasis, numbered lists, so on and so forth. So you can go look up what Markdown is and you can start to learn the syntax here. But for example, 2 hash marks here makes this into a title. 2 asterisks here, if I can ever say the word asterisks, makes this bold. All right, so that's the kind of stuff we're doing here. So what I've got then is my first chunk. I'm going to set up some of my options so that our markdown file doesn't spit out messages and warnings. I'm just going to suppress those for now. And then I've got a bit of code here that's going to load up the packages I want for this particular tutorial. So I'm using tidyverse, knitter, viridis, broom, and power. I'm going to create an object called packs. Doesn't matter what you call it. It is the list of these names essentially. Then I'm going to use the install packages function on that list, and then I'm going to load all of those packages from the library. So this little bit of code here will load up everything I need for the tutorial. So here I'm just writing text. I'm going down, and this is all the stuff you can read for your tutorial. It's all there. And I'll come down to my next chunk. And now chunks, usually it's a good idea to give them names, though you don't have to. The R here has to be there, and that tells RStudio that the code in here is R code, because you can use these files to do Python and other things. And then I'm going to give it a name. It's called simulate population. And you can see then I've got, just like my standard R script, I can do comments and I can do R code. So I'm saying I'll set the seed for simulation here. I'm trying to tell you what I'm doing as I go through. Now, when we do these things, setting the seed just means that what we're going to be doing is we're going to do some random number generation to simulate data. So if I set the seed, that means that this script will start its random seed at this value. And so if we rerun this script, we'll get the same numbers back every time, which can be reassuring. The next thing, when I say we're going to simulate stuff, we're going to use this function called rnorm. So if you come over here and you did help for rnorm, then it would bring up something about the normal distribution, and then we get a number of things we can do with that. Okay, so then we can calculate the density given a value, we can calculate probability, we can calculate quantile, and we can simulate data with rnorm. And the inputs into this function, the arguments rather, are n, which we can see down here in the help file as the number of observations I want to simulate. I've got a mean and a standard deviation. And this tells you importantly what the defaults are. So if I don't do anything, then it's going to give me a standard normal. A standard normal is a normal distribution with a mean of 0 and a standard deviation of 1. Here, I'm simulating a large number of observations. That's just running through the previous code since I decided to do this chunk with this mean and this standard deviation, which I pulled from some population level data on systolic blood pressure. All right. So what I could do is I could just highlight that bit of code and not assign it to anything. And if I were to hit Control Enter and execute that, you see what R is doing, right? It's creating a bunch of random values, but that are from this distribution. And simulation is a really useful thing to do because in statistics, what we're often doing is we're hypothesizing that there is some data generating mechanism operating, and that we see a result of that mechanism, but what we see is an incomplete representation of it. So then we're trying to take the data we see and make inferences about this underlying truth. You know, this data generation mechanism that we can never directly observe or know. That is inference, and that's what we're doing. So simulation is great because we can simulate as if we were God, so to speak, what the data are, and then we can use our statistical tools to evaluate samples from that population. That's what we're doing here. So here we create a big population of these values, and then once we've done that, then I can make a histogram very easily, and when you're working the RMD file here, it's just going to pop up below, or I could create a summary, the same thing, and just get some basic summary information. And there's tons and tons of stuff we could do And that's one of the challenges of R, is trying to come to grips with all the different functions that are available to you. And we'll just kind of work through some of these that I find useful. And we'll see some over and over again, and you'll start to incorporate them in your practice. Now, we come down to the next chunk, and all I'm doing now is I'm using another function called sample. So we can look at $sample. And I want this one. And we can see here, sample x is a vector of one or more elements from which to choose. And so the first thing I have here is I'm sampling from that population I just created. So all those values, those systolic blood pressure values I created, I'm sampling from that object, is what it's saying. I'm taking 50 of them, and I'm sampling without replacement. And then once I've done that, I'm calculating the mean of that sample. And so the important part I'm trying to communicate here in the tutorial is that this idea that we have a population, a true population that is generated by some kind of a data generating mechanism, and we are pulling samples from it, that is the idea that underlies frequency statistics, because we're going to start talking about sampling distributions now. So anyway, I've calculated the mean. So when I simulated these data, I did it with a mean of 124.5. That is our quote-unquote truth. When I took a sample of 50 from that population and calculated the mean, I got a value of 122.8. And so intuitively, we should probably understand that if I'm taking a sample from a population, that I'm not always going to get the same summary statistic or test statistic or whatever that I would get in the population. I'm getting something that's an approximation of it. In other words, if I flip a coin 10 times and it's a fair coin, I should get 5 heads and 5 tails. But anyone would expect or wouldn't be surprised if I got 6 and 4, 4 and 6, 7 and 3, so on and so forth. All right, that's kind of the nature of what it is that we're trying to do here. So we could draw another sample, and if we were to do that, we get a different value. Now, what I've done down here, when we start to do this kind of sampling and simulation, is we want to generate a lot of these samples from our simulation. And so one of the fun things you can do with R is you can start to create custom functions. So everything in R, like I said, it's objects and functions. We take an object, we put it through a function, we get a new object out. Sometimes we can create our own functions, and we do that when we want to put together a number of existing functions, or if we're going to do something repetitively that takes a lot of code, we can usually then turn that into one command or one function, and that way we're not having to repeat ourselves. So here what I'm doing is I'm creating a new function now, which is called rep means, and I'm using the code we do there is this thing function. You see it's kind of emphasized, it's special. We're telling it what the arguments are, and this little ... just means that you can also take arguments from the existing functions within our new function. Then what I'm doing is I'm using 3 different functions in my new function. And functions can be nested. And what do I mean by nested? What I mean is, here I've got a function which is to sample, just like we used above, right? That is going to sample from whatever I put in here, that number with replacement. All right, so if I were to set pop to pop SBP, and I were to set in to 100, for example. So I'm going to go ahead and set those outside of the function, right? So if I highlighted that and hit Control Enter, it gives me the thing because I just assigned that same object to that. If I hit that, Control Enter, it gives me 100. Okay, so I could do this. I could highlight just that bit of code and execute it, right? And it's giving me a sample now, right? 100 observations down to 99, 100. 100 observations from a population. Now, I've got that inside a call to the function mean. All right, so if I do this, so first it takes a sample of 100, then it gives me the mean in that sample, and then I've got a final function here which is round because I don't need all those decimal places, and it takes this mean that I just calculated and then it rounds it to 2 decimal places. Okay, so that is what this function is going to do once I execute it. And then finally, I'm going to use another function called replicate, which is to repeat a function over and over. So I'm going to replicate 100 times using this function I just did with a sample size of 50 and our population of blood pressures. Now that takes a minute to run. Not so bad. And now I can do a histogram of all of those sample means. Now, if you remember up here, our histogram, we had observed values, way down here into the 60s and 70s, way up here over 150. But now what I'm getting is I'm getting a distribution when I draw samples from that previous distribution. And so here I'm just going to get the distribution of the sample means. So it's a much narrower distribution, of course. This is what we call a sampling distribution. Again, it's this idea that if I had a population, I took samples from it, I calculated some important test statistic, some important parameter that I'm interested in. For example, I might want to know the mean blood pressure so I could plan health services. Then this would be what I would expect to see over a lot of those samples. We can use this to start making inferences about the underlying population. You can continue to go through the rest of the code here. It's the same basic idea though. We're going to use different functions. In other words, this is a function called data frame. It allows us to make a data set. It's going to be assigned to an object called studydf. And so if we were to do that, again, we could then look at that. Data frames are very special objects because they're like structured data sets, right? Where the columns are different variables, the rows are different observations. Okay, so that's our data set for this particular simulation. And importantly, what we've done here above, we just took one group and made a simulation, but now what we're doing is we're taking two groups. We're simulating some normal data from standard normal distribution, 20 observations, another 20 observations, and now I'm adding an effect of 0.5 to that. All right, so for this particular group of sampled observations, I'm adding something extra, and then we're going to try to detect that in the statistical test. And then I'm giving names to these groups. So the first group is the control, and the second group is our active. All right, so you can see that. Here I'm just doing some minor modifications to flip around these names so that they display properly in graphs, and we'll talk more about that. These little intricacies will come through and come up. Importantly here, I'm going to come into a set of functions we call ggplot, which is my preferred way of doing plots in R. There are different ways. This is what I like the most. I can control a lot of this, and you'll see as we go through all the different tutorials. So now I've created these data. I always look at data, whether it's real or simulated. Now I can see this is my control, this is my active. You can see there's more people, more simulated observations with higher values in this active group. And then we go through and we calculate a t statistic by hand, and then we go through and create a sampling distribution for t under the null hypothesis. And again, we can get more and more complicated with these plots using ggplot and so on. Okay, again, come back to the discussion board. If you want to have any questions about this, you can also leave comments on the GitHub page, although that's not as straightforward for most people. So just let us know if you need any help with this, and we're happy to go through it. All right, bye.